In this video, we'll discuss policy match criteria and types. Routes are sequentially passed into the first routing policy on the device itself, and then the routes are passed from the first term over to the next term until an action is matched. Let's take a look at an example. So the idea of the routing policies is you can have many routing policies on your device. Also, each routing policy can have many terms. Notice here that policy 1 has term 1, it has term 2, and it has term 3, before we move on to policy 2, which also has 3 terms. Now, these terms are the actual match conditions, and they have associated with them match actions. So for instance, the terms are the tests that you're creating as the administrator of the device. So when routing information comes into my device, let's say for instance, it's a OSPF routing information packet. When that comes into my device, the device is going to read the first policy, and the first policy has its first term, which is some form of criteria that it's looking for. Let's say that it's checking to see if the protocol for this routing information is OSPF. And if it is, then we want to accept the routing information. So that's the test that's in term 1. And in this case, because the routing information is OSPF information, it'll pass through that test. And because it is OSPF, the criteria is satisfied. So whatever the action is, which is accept, means we are going to accept that routing information. Now, at this point, the information stops flowing through our routing policies because accept and reject are what we call terminating actions. The information is accepted and it'll be placed in the routing table. So that's the end of the story. Now, if the routing information is coming into your device, it hits policy 1. Let's say the actual first term is testing to see if the protocol is OSPF, but let's say it's not OSPF, it's RIP, let's say. It's a RIP message. So what happens is that because there's not a match, it goes over to term 2, and term 2 is another test that would execute, right? So maybe it checks for a different protocol, or maybe it checks for something totally different. Maybe it checks for metric values, that kind of idea. So again, let's assume that the condition is not matched. So then what happens is the routing information passes through term 3. Eventually, when it hits the end of the line, it'll go over to the next policy, and then we'll have our terms tested in that next policy against the information. Now, that routing information, if there's still no match within any of the terms within policy 2, then what happens eventually is the default policy will kick in. So Juniper devices have default routing policies that depend on the actual protocol that we're talking about, and also whether it's an import or an export policy, right? So in this case, it would be an import policy because information's coming into the router, and let's say that it is OSPF, so by default would accept that information. So there is a default accept action on import policies for OSPF and RIP, but just by comparison, export policies are rejected by default for those two protocols. So that's the idea of how the policies and terms work. So here we just take a look at that in a little bit more detail. So as they mention up top here, so if a match exists and if the route is accepted or rejected, no further comparison is performed. And that's what I was talking about, where the routing information comes into the policy. The term is a match condition, so it performs a test on that information. If the information matches the test, then the action kicks in for that term, and let's pretend that the action is accept. So it's the end of the line. There's no further comparison for that routing information. It's been accepted, or maybe it's been rejected. So no other actions are performed. So just as we talked about in the previous slide, in this case, they're just talking about if there is no match in term 1, so there is no corresponding action of accept or reject, then the routing information will pass into term 2 and a test will be performed, from the conditions of test 2. So again, that only happens if there's no match from term 1. The match conditions of a policy are divided up into 2 categories. They're typically generic conditions that are performing generic tests, or protocol-specific tests, such as testing on the actual protocol or testing on characteristics of the protocol itself. Now the match conditions use what we call a from and a to statement to perform the test. Let's take a look at an example of a policy that I've created here. So within my Juniper configuration, you can see I have a policy called Glenroding policy. Now we have a curly bracket that starts the policy, and that has a matching closing curly bracket that ends the policy. So all terms of this policy would have to be inside those curly brackets. After the opening curly bracket, which begins the policy, notice that we have our first term. So term space term 1. And notice that it has an open bracket and a closing bracket to denote the beginning and ending of that term. And then here's our from statement. So we have a from. So term 1 is going to test to see if the information is from protocol OSPF. So we're doing a protocol test here. And if the information is from protocol OSPF, then we're going to accept that traffic. Whereas the second term, so let's again pretend that the information is not OSPF information that's coming into the device. Let's say it's RIP information. So then we have the second term kicks in. And again, notice that the second term does have an opening and closing bracket. And again, it has our from. So it goes and checks to see if the information is from neighboring device 192.168.1.254. If it is, then let's go and reject that traffic or reject that routing information. Also notice the use of the semicolons. So as we mentioned, it's very similar to other programming type languages with those curly bracket syntax and the semicolons to end the statement. In this video, we discuss policy match criteria and types.